So let's review our rules for multiplying and dividing with integers. So we can start with a basic statement that we all know. 2 times -3 is the same thing as having two groups with 3 negatives in each, as you see over here. And we can see that that gives us a total of 6 negatives. Well, we can take this statement and rewrite it 3 other ways. So we know that if 2 times -3 is -6, then -3 times 2 is -6 by the commutative property of multiplication. And then we know that if -6 divided by 2 is -3, then -6 divided by -3 is 2. So all of these statements fall out of the very first one, 2 times -3 equals -6. If you ever forget your rules for multiplying or dividing with negatives, all you have to do is come up with an easy multiplication problem with a negative in it, and it'll help you remember your rules. And you can see it right here. If you have different signs when you multiply, you get a different answer. Different signs, negative answer. Different signs, negative answer. Same signs, positive answer. Okay, so that tells us that if we have same signs and we multiply or divide, what's the sign of our answer? It's positive. If we have different signs, what's the sign of our answer? Negative, correct. Okay, much easier than adding and subtracting. So when you multiply fractions, the first 3 things you always want to keep in mind is 1, make sure that you can cross cancel, or see if you can cross cancel. That's really important. Number 2, after you've cross canceled, you can then multiply the numerators, and number 3, multiply the denominators. We're going to look at a pictorial representation of multiplying fractions. In this example, we have a bar split up into thirds. We're going to look at 1/3. So that's 1/3. And we want to find half of that. So half of that 1/3 is going to be right here. And in order to determine what that is, we have to split all of these up equally. So we have 1, 2, 3, 4, 5, 6 pieces now that we've split them up. So 1 out of 6 is shaded when we shade 1/2 of 1/3. So that's why 1/2 times 1/3 equals 1/6. Again, the way that we perform that operation is we multiply the numerators and we multiply the denominators. So let's look at another pictorial representation. In the next picture, we have 1, 2, 3, 4, 1, 2, 3. We have 12 equal pieces. Well, we want to find 1/4 of those. So here's 1/4 because we have 1, 2, 3, 4 rows. So one row is 1/4. And then 1/3 of that would be one of these pieces, would be 1/3 of that 1/4 piece. So that would equal 1/12. So if we were to look at this with multiplication, it'd be 1/3 times 1/4, multiply the numerators, and then multiply the denominators, and you get 1/12. So these pictures can help you see what it actually means to divide something up using multiplication. Next, it's important to remember that you never want to get common denominators when multiplying. You only do that with adding and subtracting. And the reason you do it with adding and subtracting is so that you can make everything an equal same type of piece, like a 1/2 piece or a 1/3 piece. You want to all have the same denominators. But with multiplication, you don't have to do that. So let's talk about multiplying fractions with negatives. Let's just go through and do some problems. In this example, I have negative 2/3 times 5/6. I prefer to write my fractions on top of each other. It helps a lot with cross-canceling and with multiplying straight across. So I'm going to look for any two numbers that are crisscrossed from each other that have a common factor. 2 and 6 both have a common factor of 2. Well, 2 goes into 2 one time, and 2 goes into 6 3 times. Now, I didn't really worry about keeping up with my negative as I was cross-canceling. I'm just going to look at this whole fraction itself as a negative, the negative 2/3, and then the whole fraction 5/6 as a positive. So I know I'm multiplying a negative times a positive, which is what? A negative, right? And then I'm multiplying my numerators and I'm multiplying my denominators. And then I get negative 5/9. So let's try another one. Negative 8/9 times negative 27/64. So with 8 and 64, they both have a common factor of 8. 8 goes into 8 one time. 8 goes into 64 8 times. With 9 and negative 27, 9 goes into 9 once. 9 goes into 27 3 times. Again, I'm just going to remember my first fraction is negative, my second fraction is negative, and when you multiply two negatives, that gives you a positive answer. So my numerator is 1 times 3. So I already know this is positive. I don't need to bring any negatives over. My denominator is 1 times 8, so I get 3/8. Let's look at working with mixed numbers. Now, when you were adding, you always kept mixed numbers mixed, and then you would borrow or regroup if you needed to. Well, when you're working with multiplying or dividing, because we end up multiplying the numerator times the numerator and the denominator by the denominator, we have to change them to improper fractions. Otherwise, we don't really know what the numerators are. So let's change negative 6 2/3. So negative 6 2/3 times 5/9. So 3 times 6 is 18, plus 2 is 20. So this is negative 20/3 times 5/9. So I'm going to check and see if I can cross cancel anywhere. 3 goes into 9, but not into 20, and 9 doesn't go into 20. And 3 and 5 are both prime numbers, so there's no cross canceling that can be done here. So I need to multiply the numerators and then multiply the denominators. And I'm going to get negative 100 over 27. Then I need to change this to a mixed number by dividing 27 into negative 100, or you can just remember you're going to have a negative. And it's going to go 3 times. So that's an 81. And I subtract to get 19. So I have a remainder of 19 over 27, and it'll be negative. So that gives me an answer of negative 3 and 19/27. So we want to check for cross canceling. When we have mixed numbers, we want to change them to improper, and then check for cross canceling. So now we're going to talk about what you can do when you have multiple fractions, where you multiply them all at once. And it is important that you learn the skill of doing it all at once instead of multiplying the first two and then the answer to that with the third one. I don't want you to do it that way. That's the long way, and the short way is going to teach you some important skills. So you can cross cancel any numerator with any denominator. So that means I can look at this 8 here and see if it could go with a 15, an 11, or 24. If it has a common factor with any of those, I can do cross simplifying. So 8 and 24 have common factors of 4. 4 goes into 8 twice. And don't worry about keeping up with your negatives. 4 goes into 24 6 times. Ah, look, I didn't go far enough. So I really should have divided by 8, right? 8 goes into 8 once. 8 goes into 24 3 times. So now I'm going to keep going. Well, 55 and 15 have common factors. 5 goes into 55 11 times. 5 goes into 15 3 times. So now what I'm going to do is check all of my numerators and all of my denominators and see if there's anywhere else I can cross cancel. Well, 1, I can't do anything with that. 11 and 11 are crisscross from each other. So one's a numerator, one's a denominator, so I can cross cancel there. And then either one of these 3's could cross cancel with the 6. I'll do the blue one. 3 goes into 3 once. 3 goes into 6 2 times. So when I'm done, I should have no numerators that have a common factor with any of the denominators. And if that's the case, I should not have to simplify. My numerator, I like to write down all the 3 numerators so I don't lose any of them, and all 3 denominators so I don't lose any of them. And double check my signs. I had a negative and 2 positives. Well, if you have an odd number of negatives, you're going to have a negative answer. So this is negative 2/3. So in other words, we had 1 negative here. If you have 1 negative times positive, you're going to have a negative. If you have 2 negatives, you're going to get a positive, even if there's another positive in there, right? Because that would give you a positive. If you have 3 negatives, that's an odd number of negatives, right? And so that would give you a negative. So if you have an odd number of negatives, your answer is going to be negative. If you have an even number of negatives, the answer will be positive. Anyway, you can always just multiply it out. Whoops, that should be negative. All right, so that gives us negative 2/3. We're going to keep going. So try this one, pause the video, come back, and see how you did. I'm going to show on my cross canceling. You can skip that if you'd like. And you don't have to do it in the same order that I do it in. 5 goes into 5 once, 5 goes into 25 5 times. Let's see, I've got a 9 and a 24. 3 goes into 9 3 times. 3 goes into 24 8 times. I have a 15 and a 12. 3 goes into 12 4 times. 3 goes into 15 5 times. It's like a puzzle. I have 14 and 21. 7 goes into 14 2 times. 7 goes into 21 3 times. Now I'm going to double check my numerators and denominators. I already see something. So I have a 5 and a 5 that'll go into each other. A 2 will go into the 2 and the 8. And then I have a 4 here and a 4 here. And then I have a 3 here and a 3 there. Wow. So let's look. We have 2 negatives and 2 positives. So our answer is going to be a positive. Our numerator is 1 times 1 times 1 times 1. Our denominator is 1 times 1 times 1 times 1. You don't have to write all that out, but it just helps you keep up with everything. So this is kind of cool because we end up with 1. All right, let's look at the next problem. Here you're just going to change this to improper and multiply. Make sure to check for any cross canceling, also known as cross simplifying. give this a shot.